Hello, today I discuss about thermal conduction. Heat energy transfer from hot object to cold object. Heat energy is transfer from hot to cold. That means higher temperature object to the lower temperature object. And this transformation of heat energy have three types of modes. Heat energy is transferred from hotter place to the colder place by three modes. One is the conduction, another is the convection, and another is the radiation. Conduction and convection, these two processes takes place through the material medium. That means without material medium, the heat cannot be conducted or convected. But by the process of radiation, heat can transfer through the vacuum. We get heat energy from the sun by the process of radiation. Generally, the conduction takes place through the solid, but some exceptional is there. That means here the mercury is the liquid, it can conduct heat. Generally, the metals are the good conductor of heat. The quantity of heat conducted through the solid depends on the 5 factors. One is the area of the cross section, difference of temperature of the two region, that means hot and cold region, the time and distance between the two surfaces, that means distance between the hot and cold surfaces, and lastly it is the material of the medium through which heat is conducted. Now you consider this is a conductor. Here the temperature is T1, this surface has the temperature T1 and this surface have temperature T2, and T1 is greater than T2, that means it is a hotter surface and it is a colder surface. So heat is transferred from this surface to this surface. Let the Q amount of heat is transferred at a time T. The distance between these two surfaces is say L, and the cross section of each surface is capital A. The amount of heat conducted is directly proportional to the cross section. That means if the cross section is more, then the conducted heat will be more. Difference of temperature, that the conducted heat is directly proportional to the difference of temperature of the two surfaces. If the difference of temperature is more, then the heat flow will be more. That means when the time goes on, then the difference of temperature of the two surface decreases, so the heat flow gradually decreases. Now the heat flow is directly proportional to the time. If you give more time, then the amount of heat flow will be more. Now the distance between the two surfaces, the heat flow is inversely proportional to the length. If the length is more, if the separation of the two surfaces is more, then the heat flow will be less. Now thirdly, it was the material. And now if you join these four relations, then what you get? Q is directly proportional to A into T2 minus T1 into T divided by L. A T1 minus T2 into T divided by L. Now you remove alpha, then what will you get? Then you get a equal sign and a constant, and you take either the constant is K. So Q is equal to K A T2 minus T1 minus T2 into capital T by L. Here the capital T is the time. Now this proportional constant K is known as coefficient of thermal conduction or only thermal conductivity of the material. This is a constant, but its value depends on the material of the conductor. Different materials have different thermal conductivity. This value of K, that means thermal conductivity, depends on the material of the conductor. It does not depend on the conductor. Say for example, here we take two conductors. Here both are made by copper, but their size are different. Two conductors have different cross section and different length, but both are made by same material. As they made by same material, so their thermal conductivity will be same. But amount of heat conduction for a particular time will be different because their cross section and length is different. Now, what will be the unit and the dimension of thermal conductivity? We know that Q is equal to Ka T to the power T1 minus T2 into T by L. This is the formula for amount of heat conduction. Now, find out K is equal to, then these will be transferred. So L here is the division, so it will be multiplication. So Q into L, and all of them will be divided A T1 minus T2 into T. Now the dimension of K is the dimension of Q. Q means the heat energy, that means energy. So it is mL square T to the power minus 3 minus 2. This is the dimension of energy into L, that means length. Area, that means dimension is L square, is the temperature, it is a theta, and it is the time T. Here the L square and L square will be cancelled, so it will be m L, here T to the power minus 1 minus 2, and here the divided by T, so it will be T to the power minus 3 and theta to the power minus 1, and it is the dimension of K. Now unit, here the SI unit, here the SI unit of heat energy, that means energy, it is joule. Length, it is SI unit is meter. Area, the SI unit is meter square. Temperature, it is the Kelvin, and time, it is the second. Here the meter and meter square will be cancelled, it will be meter, so it will be joule by meter Kelvin second, that means joule m to the power minus 1, k to the power minus 1, and s to the power minus 1. This is the SI unit. Now we know that this portion, that means joule by second, that means joule per second. It is known as watt. So watt, m to the power minus 1, k to the power minus 1, it is another unit, SI unit of thermal conductivity. Now if you consider the dimension, from dimension what you get as a SI unit? Here the m means kilogram, L means meter, T to the power minus 3, that means second to the power minus 3, theta to the power minus 1, that means k to the power minus 1, and it is the also a SI unit according to the dimension. This is the thermal conductivity of the material.